Hi everyone, this is Infinity YouTube channel. Please remember to like, subscribe, and share. So today we are going to work on the inverse Laplace transform. Then we are going to see how we can determine the inverse Laplace transform. The other time we talked about the Laplace transform, and then we derived some certain f of t's, and we saw how when we integrate those f of t's, what function it is going to give us. So today we are going to work on the inverse, right? And then we are going to see how we can convert back to the original f of t. From the beginning, we're told that the Laplace of f of t, f of t is equals to the integral from 0 to infinity exponential of minus st f of t dt, right? So this is the definition of the Laplace transform. And from the last video that we did, this was the definition that I gave. But mind you that this definition as well is equal to f of s, right? So remember from what I said earlier on that the definition of this Laplace of f of t is to enable us convert functions from t to s. So if you successfully convert those functions from t to s, the answer you're going to have will be f of s. So today we are going to convert f of s back to f of t. That is what we mean by the inverse of the Laplace transform. Hence, the inverse Laplace of f of s, the inverse of f of s will now be equal to the f of t, right? So if you have the inverse of the f of s, what you are going to arrive at will be the f of t. So we are going to go through some certain f of s, and then we are going to see its conversion to f of t. Alright? So from what I have here, so the question will be determine the inverse of the following. Determine the inverse of the following, the inverse Laplace of the following. So determine the inverse Laplace of the following. I have 1 over s squared minus 1. I have s over 5 into s squared minus 4. And then I have 3 into 2 of s squared plus 9. So these are the first 3 examples I have. So we are going to go through this example, and then we are going to see how to convert this f of s to the f of t. Alright? So the first one we are going to go through is the I. So on the I, we have that, before that, remember that these functions that are written are f of s. Are you there? So the first thing you have to do is to say f of s is equal to the first one, that is 1 over s squared minus 1. 1 over s squared minus 1. Right? So, how do you determine this inverse Laplace transform? So, when you are given a function and you were asked to determine the inverse of that Laplace transform, the first thing you have to do is to look at the denominator. You use the denominator to decipher which type of f of s and which type of f of t you are going to have. Alright? So when you look at this one, looking at the denominator now, we can see that 1 can be expressed as a square, right? We know that 1 squared is equal to 1. So since 1 squared is equal to 1, we can simply write this as this is equal to 1 over s squared minus 1 squared. So this is what we are going to have. So which f of t from the Laplace transform that we did earlier on can give you a denominator in this form? So the one that can give us denominator in this form will be when f of t is equals to sinh 80. So sin 80, depending on however you pronounce yours, right? So when f of t is equal to sin 80, so when that f of t is equal to sin 80, the original f of s that was equal to that sin 80 was when we had that the Laplace of sin 80 was equal to a divided by s squared minus a squared. So this was the definition of the Laplace of sin 80, right? Alright, so since these and these look alike, hence it means that a is equals to 1. So since a is equals to 1, then the f of t, which is the inverse Laplace transform, as you can see, the f of t is the inverse Laplace transform. So the f of t is now equal to sinh, instead of now writing a, since a is equals to 1, just sinh t. So this will be the answer to the first one. Now the second part of the question now says that the f of s is equal to s divided by 5 into s squared minus 4. Alright, so this is what we have. So as usual, the first thing you have to do is to look at the denominator first. So we know that all the Laplaces that we solve, all the f of c's that we solve at the first instance, all the f of s as well, there was no number at the denominator, right? So what we have to do is to factor out these 5 outside of the function. So if we factor out 5 outside, what we are going to have will be 1 over 5 into s over s squared minus 4. But remember that 4 can be expressed as 2 to the power of 2. So I can decide to write this 4 as 2 to the power of 2, right? Good. So having this now, if you look at this function that I have inside, it looks familiar to one of the Laplace of f of t that we've done before. So which f of t represents this kind of denominator? So the f of t that represents this kind of denominator is the cosh of 80. Okay? It's actually the cosh of 80 because we know that the inverse, we know that the Laplace of cosh 80, the Laplace of cosh 80 was actually equal to s over s squared minus a squared. So this was the definition of the Laplace of cosh 80, right? So since this is equal to b, if we compare these two values, it means that a is equal to 2, right? So since a is equal to 2, it means that the answer to this question now will be f of t is equal to cosh 2t. But remember that 1 over 5 was outside of the function. So what you do is actually to put 1 over 5 out of this function. So this is the answer to this question. Now on the last one on the list, we have that 3 over, what we have here is 3, that f of s now is equal to 3 over 2 into s squared plus 9. So this is what we have, 3 over 2 into s squared plus 9, right? So since we have this, as usual, we have to factor out the constant that is inside of this function. So if we factor out the constant that is inside of this function, what we are going to have is, this is now equal to 1 over 2 into 3 over s squared plus 9. So I would advise you, when you are trying to factor out, do not touch the numerator. Always factor out the denominator, the constant in the denominator. Do not touch the numerator. Alright? So now let's continue. Now when you have this kind of function, so what type of f of s looks like this function? Which type of f of s looks like this function? Now the type of f of t that can actually give us this will now be f of t of a divided by s squared plus a squared. So this is what we have, right? So how can you easily determine these functions? Just look at the numerator, look at the denominator. As you can see, 3 is a square of 3 squared will give us 9, right? If you square 3, you are going to have 9 as your answer. So since if you square 3, you are going to have 9 as your answer. That means this kind of function resembles this, right? So from what we know that the Laplace of sine 80, we know that Laplace of sine 80 is equals to a divided by s squared plus a squared, right? When we found the Laplace of 80, this was what we had as the answer, right? So now how can we now compare, when we compare these two, how can we now decipher the answer? So from what we can see here, it clearly means that a is equals to 3. So since a is equals to 3, it means that the f of t, which is the inverse of this Laplace transform, is now equal to 1 over 2 sine 80, but a is 3, so sine 3t will be the answer to this function. Are you here? So this is a very simple example. So we are going to go through another set of example. So I advise you to pause the video as I'm going to write this other example. Then you pause the video and try the example and see if the answer you are going to have is the same as mine. Are you there? So the question is determine the inverse as well. So determine the inverse. Determine the inverse of the following. So you are going to determine the inverse Laplace transform of the following. So the first one you are going to determine will be, from what I have here, s into s squared plus 1. I have 1 over 4 into s plus 2. And I have, the last but not the least there, I have 1 over s to the power of 4. So you feel free to pause the video and try this function. So if you have done that, let us quickly find the f of s and f of t that are related to this function, right? So the first one, from the first example there, we have that under the I now, we have that f of s is equal to s divided by s squared plus 1, right? So if f of s is equal to s squared plus 1, though this remember from what I explained when I solved this particular question, I told us that 1 can be expressed as 1 squared, right? So let me write this one as 1 squared. So if I write this as 1 squared, we can clearly see that the f of t that is related, sorry, this should be f of s, right? So the f of t that should be related to this function, the f of t that is related to this function will be f of t of cos 80, right? So the f of t that is related to this function is f of t cos 80, because we know that this function can be written as, this f of s can be written as s divided by s squared plus a squared, right? So we know that this can be written as s squared plus a squared. Now, if from what we did earlier on, if you find the Laplace of cos 80, what you are going to have will give you s divided by s squared plus a squared, right? So this is what we got initially, okay, from the first video that we did, right? So if you now compare this and this, you can clearly see that a is equal to 1. So since a is equal to 1, that means the f of t that is equal to this function, the f of t that is equal to this function will now be equal to cos t, because a is equal to 1. So that is just the final answer to that question. Alright, so the next one we are going to find is the III, which is, okay, the III, let me just fix it here. So we have that the f of s here on the III is equal to 1 over 4 into x plus 2, right? 1 over 4 into x plus 2. So as usual, I told you that factor out the denominator outside of the function. So when we factor out the denominator now out of this function, we are going to have 1 over 4 into 1 over s plus 2, right? If we factor this out, this is what we are going to have. So which f of s represents this kind of function? Which f of s looks like this? You can clearly see that this function can actually be rewritten as, we can decide to write this function as f of s, which is now equal to just this function, which is now equal to 1 over s minus a. This looks like this and this resemble each other. So, and which type of Laplace of f of t can give you this kind of function? Which f of t can easily give us this kind of function? We know that when f of t is equals to the exponent of minus 80, we know that when f of t is equal to the exponent of minus 80, that the answer it is going to give us will be 1 over s minus a. So if the Laplace of the exponent of minus 80 gives us s minus a, that means that the Laplace of positive 80 will give us s plus a, as you can clearly see from here, right? So if we should compare this and this together, we can clearly see that a here is equal to 2. A is equal to 2. So since a is equal to 2, but remember we know that 1 over 4 is outside of this function, right? So since 1 over 4 is outside of this function, the answer becomes, the f of t now becomes 1 over 4 exponent of 2t. Exponent of 2t. So that will be the answer to this function. That will be the answer to this function. Alright, so but sorry, when you say get the Laplace of this, so this is what you are going to have. You are going to have, when you have the Laplace of exponent of 80, you are going to have s minus a. Sorry about that. When you have the Laplace of exponent of 80, you are going to have s minus a. Then, but when you have the Laplace of minus 80, you are going to have s plus a. Alright, so this is what we derived from the first function that we did. Okay, so since we have a positive here, that means there's going to be a minus. So this should be 1 over 4 minus 2t as the answer to this Laplace. Alright, so on the last but not the least, we have 1 over x to the 4th power. 1 over x to the 4th power here gives us, on the III now, we have when f of s is equals to 1 over s to the 4th power. So 1 over s to the 4th power here, as you can see, this clearly shows us that f of t should be equals to t raised to the power of 3. Okay? Because when we found the Laplace of t raised to the power of n, what we got there was n factorial divided by x raised to the power of n plus 1, right? So that is to show you that this was basically for you to get s to the 4th power here, you must have, it means that the n was 3, the value of the n was 3. Remember what I told you, don't look at the numerator, the first thing you should look at is the denominator of the function, right? So since I look at the denominator of this function, it clearly means that n is equals to 3, right? So n was equal to 3, right? Alright, so let's continue. So if n is equal to 3, if you make n to be 3 here, let's just go. It means that what we are going to have, if we find if f of t is equal to t cubed, it means that this should give us, from here, since n is 3, it should be giving us 3 factorial divided by s to the power of 3 plus 1, right? So on the normal, this should give us 3 factorial means 3 times 2 times 1. That means this should give us 6 divided by s to the power of 4. But if we should, if f of t of when f of t is equal to t cubed, we know that the answer should give us 6 over s to the power of 4, right? But looking at this function that we're given, what we have there is 1 over s to the power of 4. So what comes to your mind is, what should I do in order to eliminate the 6 out of this function? So what we should do is to multiply this by 1 over 6, right? So if you should multiply this by 1 over 6, as calculated, it can cancel out and we will have 1 to the s to the power of 4. So which means that the f of t that was present, the inverse Laplace transform now will be equal to 1 over 6 t raised to the power of 3. So this will be the value of this function. So I believe this was actually very clear and easy. So I will give you an exercise to do. When you are done, just drop the answer in the comment section, right? So we are going to find, we are going to determine some inverse Laplace transform. Okay, so I'm just going to erase some functions here, and you are going to determine the answer of those functions. All right. So the first one I have here is determine. The first one I have here is find the inverse Laplace transform of the following. A, we have 6 over s squared plus x6. We have 1 over x plus 3. And then we have I. We have 1 over s minus 2. IV, we have minus 3 over s plus 1. And the last but not the least is V. We have 4 over s plus 3. So determine these functions and put your answer in the comment section. So I hope this video was useful and helpful. Please remember to like, subscribe and share. So as usual, this is Infinity YouTube channel. Please remember to like, subscribe and share. Thank you.